1.8. Outline Thomson's experiment to measure the charge-mass ratio of an electron. You would have learned about J.J. Thomson in the dot point 1.1 about the inconsistent behaviour of cathode rays. So what was his experiment? He passed cathode rays through two narrow slits to make a thin parallel beam aimed at the centre of a fluorescent screen. Electrodes were then placed to create a uniform electric field that exerted a downward force on the beam. Electromagnets were placed to produce a uniform magnetic field that exerted an upward force on the beam. Through Thomson's manipulation of the strengths of the two fields until the beam passed through both fields undeflected. This showed that the two forces on the particles in the beam were equal and opposite. By equating the expressions of these two forces, Thomson calculated the velocity of these particles. Thomson removed the electric field and calculated the radius of the circular path followed by the particles in the uniform magnetic field alone. By equating the force due to the magnetic field to the centripetal force, he was able to calculate that cathode ray particles, or as we know they are called electrons now, had the same charge over mass ratio of 1.76 times 10 to the 11 coulombs per kilo. So looking at the apparatus on the right hand side, that's similar to what Thomson would have used. So Thomson's tube for measuring Q over M for the particles of the cathode ray tubes. So electrons from the cathode C pass through the slits at A and B and strike the phosphorus screen at S. The beam can be deflected by electric field, which we've learnt previously, between plates D, and F for the magnetic field, which we've learnt previously about magnetic field manipulation. So quite a simple experiment that he was undertaking at the time. However, very little was known about cathode rays, and this is why there were so many inconsistencies to the behaviour and basically the start of the atomic structure and knowing what the charged particles were. Giving it a unit such as the charge mass ratio was fundamental at that time.